record this too, just so we'll send out a link. I'll send a link with the Dropbox link to this a little later today, just in case anybody has any questions or wanted to go back and look through it. Today, what we're going to go through, I'm calling this basic analysis tools. So within ArcGIS Online, you have the map component and everything else. But within every map document, when you're within the map, and actually let's backtrack a step here. So let's say I went to content, and you could either start from a blank map, and I created it, but I'll just go to the one that I created earlier that I just populated in some data that we'll use as sample. So, but to get there, when you're in the actual map window, you're going to click on the Analysis tab. From here, they're sort of segmented into categories, and there's a number of things that do a lot of things, many of which you'll never need. So today we're going to highlight a few that I think are actually kind of important and probably pertinent to what we're doing. So with that, let's actually start with join features. This one is a join is a really very basic GIS term where you're either connecting something based on let's say a common number or a common variable, be that building name or zip code or whatever else. But the exciting one that I think is the really fun one and what makes a GIS really wonderful is using a spatial relationship. So let's go back over here. And I'm going to let's turn that off. I'm actually going to use, for our sample here, I've got a list of, let's say we'll use that. We have a list of buildings, and just as a sample geography, this could be anything, but I just pulled in a census tracts. Doesn't have to be anything. This is just use it as a sample.
Sorry, ignore that, Brian.
No problem. All right, so let me go back to analysis here. I'm going to go back to summarize data. And again, they're kind of grouped based on what they do. So I'll go to join. I'll click on find location of buildings. Let's click on tract boundaries. And I'm going to join based on a spatial relationship. So what I'm taking is from this building point is going to get everything from the area that it falls within. A couple other things here with this join one or one to many. 99% of the time it's going to be one to one. So you're really connecting this join to this tract, or excuse me, this building to this tract. So I would almost by default leave it as one to one. When in doubt, leave it as one to one. And then let's save that. Now let's hit run. It's going to process for a sec, and we should get a layer with our buildings and with the information from the census tract. Watching if it takes a second. Also ported up a basic one here too that had so in this case, this is while it's thinking there, this is the result we'll end up getting. Okay. Oh, cool. So it's going to show us the buildings that we pulled, and again, just this sample data pulled out of Coaster, so it doesn't mean anything. And this will show what census tract it's joined to. But if you wanted to know, had a list of buildings or what have you, and you wanted to know what submarket, what zip code, what city it's in, you can join that to those layers. Also within analysis tools, we're going to use summarize nearby. And this can actually kind of summarize what data is in the area. So in this case, we'll start with this one building, and we'll summarize the other buildings in the area. We'll see what's within a mile. And in this case, we just want to figure out for the rental building statistic, how much, let's say how much supply is there in the area. And maybe we could even just find an average. This just for sake of sample. click run. And when that's done, we'll get something like that. Well, it'll actually show us, hey, within that 1 mile, there's about 17 million square feet of office product based on our sample list. Okay, this could be how many points are within that radius, could be what the average is. We could also do this, you're looking at some more advanced statistics like rent and vacancy and anything else. All right, so those are just a couple of summarized data. Let's actually move on to find locations. So, and this is basically using a sort of kind of a couple of query sort of tools. So let's actually turn those, and I'm just going to take these out just so our list doesn't get too cluttered here. So let's go back to our analysis. Let's go to find locations, and let's go to find existing locations. So let's actually let's pick on our list of buildings again, and I want to pick out buildings where, let's say, the RBA, let's say it's greater than 1.2 million square feet. In this case, it was just an office list that was just run out of CoStar. That was, I think, an office over 1 million square feet in a couple of submarkets. So again, oops, and let's give it a new name. So we'll give that a sec. And again, as always with these things, if anybody has any questions or I'm going too fast or wondering how this works, all those things, please let me know. So while that processes, here we go. So it'll pull that layer, it'll actually extract out a new layer that just matched those particular buildings, and it'll show, again, the options that came up. So a lot of this is if you have a really huge data set and you wanted to just filter out something like if you had a data set that had multiple types of properties, if you just wanted to circle out things where maybe the vacancy was higher, the rent was above a certain threshold. That's a great tool to use out of that. Going back to find locations, we're also going to use drive new locations. And the same thing here, similar thing here, we can actually use let's pick a different layer here. We can do both what I would call a numerical spatial join and a locational. So this is we're using it both a numerical query and a spatial query where we're saying we want to pull all the buildings that are within that radius ring we created earlier. This is going to be almost everything, but again, similar query. Again, we hit run, and in a second it'll pop open with a new layer. Going beyond that, let's actually skip ahead to, we're going to go to data enrichment, which is, again, pulling in some additional information and connecting it to a layer. So let's go back over here. And let's just take that out. We'll clean up our list a little bit. This is our new layer that we just created. Again, figuring out everything that was over that square footage range and within that area. So let's select that area. And the cool thing is here we can actually connect it to, this is where it connects with Business Analyst, and we can actually pull in some information. So let's say I want to find out what the median income area is in that area, what is the total population, and let's say what is the average retail spending. So apply, And let's say we already picked an area, so we actually picked this 1 mile radius ring here. Let's give it a distinctive name. Let's click run. So all that buffers, that's actually going to return us more of a table that actually shows the demographic variables in here. A lot of this is what I would call background GIS tools, where it's as much about creating a map, but also using a map as a data tool. So what we're actually using is data and geography as that tool to draw statistics and information. So if we click on that, let's scroll over here. So it's going to tell us within that area, the median household income is about $82,000. There's about 10,500 people, and the average household spends about more like $2,600 on retail goods. So moving on down the road. A couple of these are a little more basic, but again, they're within here, and I think these are going to be pretty common things you guys are going to end up doing. So again, if you punch in an address, that's great, but we want to show where it is in relationship to everything else, or want to show how far out you, maybe like a walk time or something like that. So we can create what they call a buffer, which is really another word for creating a radius around it. This could be around, in this case, we'll do it around a point. Or a series of points. But it could also be around a shape or a line or anything like that. Like the buffer, the other use proximity here that I think is the really fun one here is the drive time. So, and don't let the drive time mislead you. It could be a lot of things here. So within this, you have a lot of options where by default it comes up to drive time. And the cool thing is with drive time, let's turn that on. With drive time, you can actually, the real fun thing is you can actually use traffic. It's like right now I could use traffic, but it's 1:15 in the afternoon in Chicago, so traffic's not going to be that bad. But if I wanted to say base it on traffic on Wednesday, and let's say at 5 p.m., where we're going to get very different traffic conditions, we can do that. But going back into there, the other really fun thing here is that it has a lot of these other pieces. So some of these ones you may not use as much, but it varies around based on a couple different things. Walk time is going to be dramatically different, that it's estimating using the transit grid, be that streets and roads and everything else, estimating at about the speed of a person walking, which is about 3 miles an hour. So it's going to be a dramatically different looking shape than if you looked at a drive time. Rural driving distance, probably less that we're going to need. It'll also do driving distance. So again, it's still taking in the road network, but if you said that it can only, something needs to be within 5 miles of this location, it's actually thinking of that using the road grid. It won't necessarily be a ring like this. It'll actually be kind of the jagged shape based on the road grid. Same thing with walking distance if you wanted to show everything within, say, that 1 mile walk of a particular location. Additionally, too, if you're working with like an industrial client or a logistics building, it also has trucking time and truck distance. So let's actually let me do a walk time here and just kind of show you what that would look like. And that's going to set process for a second. Again, any questions so far? Okay. So, and again, and while we're at it, we already have this one ported up. This was an actual drive time. This shows what. Oh, there we go. So actually, this one in the lighter purple that you'll see, this is what a drive time looks like, whereas this walk time is based on the walk speed. So again, you see very dramatically different shapes. In an area like that's gridded here, like in the Loop in Chicago, you get this kind of a little more regular shape with the walk time, whereas the drive time is very, very linear. And as you notice, like over here where you get onto the highway, that you get these interesting linear shapes. Drive times are a lot of fun, I think, and they really do tell much more on the ground story of what's going on with traveling distance from a particular site. So with that, we're going to round third, and let's finish out with managed data. So let's talk about extract. I'm going to talk, let's again use our buildings layer, and let's say our study area, we can actually draw in something here. So if I just wanted to find everything that was this will actually select features that are either A, within the boundary, or I could say within a walk time, and it'll select those features, and it'll actually export it out into a couple of different things. I could have it export out to a shapefile, geodatabase, a KML if you wanted to drop it into Google Earth, or a CSV. There we go. And that'll be available on my content when that is done. Let's go back. Let's look at some more managed data tools here. Additionally, there's the merge layer tool here. So if you had two different types of data or two different data sources that you wanted to merge, you could do that. Caveat with this is I would say keep it, be it point to point or polygon to polygon. Just kind of compare it, make sure it's apples to apples. So something like, let's say if I wanted to take our building list, merge it with 200 Madison. Those are 2-point layers, and I would say give it a name. And run that analysis. All right. And well, I've got you one more thing within the managed data. This is really big. This one I think is a really powerful tool that it has, and one I think you're going to find exciting. This is the extract layer. So if I wanted to, again, use our building list, I'm going to take let's take our walk time here, and it'll select out those pieces that are within that area. Or actually, let's do this. Let's take that buffer, and let's take that travel time. It'll extract the pieces that are overlapped in the two. So let me actually, let's turn on those two layers. So let's say I've got a radius here. We have a 5-minute drive time. So let's actually try and figure out let's use intersect to extract this piece in here. So, sorry, there we go. Going back to analysis. I use my overlay. Let's use that buffer. Let's use that travel time. And we're going to use the areas that are, and we're going to use intersect here. You could also use it to actually clip out to combine these two layers and erase the overlap too, just for future reference. Let's run that. And that's going to process, and that's going to give us the space in the middle that is overlapping both. So, and while that processes, that's going to be up in a sec. That's about what I have to show everybody today. As you look through here, there's a lot of stuff that you may or may not need. Like you're probably not going to do hydrology, so I don't know if we're going to need to create watersheds or anything else. Viewshed might be more interesting. Viewshed's actually a really cool one that I'd urge everybody to take a look at, but there's a few things in here. But I'd say get in there, try to bring in some sample data, or think of a project that you want to work through, and take a shot with it. Oh, here we go. So that is our cutout shape. So you can kind of see the radius and the cutout where the walk time is. So with that, any additional questions?
Is there an optimum number of layers? Well, maybe not optimum, but at what point do you have too many layers to where it slows the program down?
Oh, I would say slowing it down is not really the issue. Confusing yourself is probably the issue. Like right here where I pulled in a bunch of stuff where we're trying to, where we went through, I think, 12 tools. I potted over some stuff just to have as a sample. This is confusing me and I would want to clear this up. But I would say anything as you go, since sometimes you may do this as an iterative process where you may start with one data set, incorporate things, and go in steps. Kind of clean up your work as you go along. So I would try to keep it under like 4 or 5 layers at a time if you could. Okay. I don't always stick to that advice, but that would be what I would tell you to do.
Thanks.
All right. Well, thanks everybody. So my apologies, this one was not necessarily super fun, but we just wanted to show everybody what the tools actually do. So again, if you have any questions, please reach out to me, and I'm happy to walk you through anything. A recording of this will be released later, and I believe I sent out the PDF with the tool descriptions earlier, but that'll be on an email that comes out later today again with the recording. But thank you all for your time today, and have a great rest of your day.
Thanks, Brian.